the best I can to get through this. May not have quite the energy I normally do, and I'm sorry. I'm gonna be disappointed doing this. I'm sorry. This is such a fun lesson to teach too. I hate that I don't feel 100%. Okay, let's review before we get to the actual long division. Let's review first division by a monomial, and then maybe even by a binomial. Oh, let's just start. Oh. This is not you, Jason, not yet. Yeah, you're doing a great job. Maybe scrunch the curls just a little bit. Perfect. Okay, if I divide by a monomial, tell me what I do. We did this way back at the beginning of polynomials. How do I divide them though? I'm going to split this into 3 fractions, right? This only works when I'm dividing by a monomial, which is one term. And I'm going to split it up. And then somebody said subtract, and you're exactly right. Minus 15x cubed over 3x squared. And it just becomes 3 separate problems like we did with the properties of exponents, right? Y'all remember this? Everybody okay? All right. So each one of these would simplify 2x squared minus 5x plus 1. Everybody okay with that? Okay. Do you also understand, and I wrote this at the top of that board over there, that I could write this a couple of different ways. I could write this as a fraction. I could write it in a division sign. We always called this a little house. I don't know what y'all call it. It's hot in here again. But I could also write it as a division problem itself with the actual division sign. I say all this because you'll be given them in all 3 ways and have to interpret and go back and forth. Bless you. So understanding is just remembering which one's on top, which one's on the bottom, or which one's inside the house and which one's outside the house. All right. I think we'll just jump straight into the one instead of going into factoring. By the way, dividing is just a way of factoring. If I tell you that, does that make sense to you? If I asked you to factor 6 into its prime factors, what would you tell me? 2 times 3. So if I said 6 divided by 2, I divide by a factor, I get a factor, right? So essentially dividing is another way of factor. Okay, and we'll get to all that probably tomorrow, maybe even the next day. But just let you know. All right, you ready, Kason? This is your time to shine. Yeah. Okay, I'm going to put a problem up here. We want it to be a good problem. All right. Let's write this another way. Let's set it up in our house. What goes on the outside? X minus 2. And inside the house, now I will tell you as you set this up, make sure whatever exponent, this is getting increasingly more difficult. Make sure whatever your biggest exponent is inside the house. Henry, I think of you every time. Whatever that exponent is inside the house, that biggest one, make sure you have that and every exponent below that. So in other words, if the biggest was a 5, I need to make sure I had 4, 3, 2, 1, and constant. This one starts with 3. So what happens if I don't have it? I would just put a 0 to hold the place. We call it a placeholder. And we'll do one with a placeholder in a minute, but I just want to make sure I told you about a placeholder first. All right, so I'm just going to write all this. This one doesn't need any placeholders because if you look, I have 3, 2, 1, constant. Make sense? Okay. Take a look at Kason's board. Kason, what if I am working that problem? What is it that I do first? Tell me my first. Think about this as a kid who has never seen long division before in their life, and you're teaching them how to do this, what would you tell them to do first?
How many times can you fit 5 into 7? Okay, so you put a 1 up here, right?
So you put a 1 up there, and just do that one step. Don't do anything else. Okay. So we put a 1. I'm going to do the same step with the polynomial.
Olivia, please stop making faces. It's how I feel. Perfect. No, I think you can see it.
Okay.
No, it doesn't. Stop lying.
Mr. Kennedy.
Oh, I thought it was for your IGP.
It is. It's for both.
Oh. Okay, so the difference here, I only look at the first term. That could have 3 digits, 4 digits, whatever on the outside. This one, I'm only going to look at the first term here and the first term here. So x goes into x cubed how many times? Okay. Okay, let's say it a different way. X times what gives you x cubed? X squared. Think about this being set up in columns. So the x squared is going to go above the squared. Does that make sense? First terms only. Somebody said no. First terms only. X times what would give me x cubed? Just like 5 times what gets me as close to 7 as I can get. So x times, without going over, you can't go over, right? You can't go over. So as close as I can get without going over here, x times what gives me x cubed, x squared. Okay? Think about this being in columns like this. I feel like I'm not doing this as good a job as I'm doing. I'll get y'all there, I promise.
Wait, so why does that go in that column?
It matches
The x squares. So anything with a square will be in this column. Anything with just an x will be in this.
It's not that's the
I was talking to myself.
Okay. Kaysen. So Kaysen, what we do next if we are doing long division in that problem? You multiply around, right? 1 times 5 gives you 5, and you write it where? Underneath. And don't do anything else yet, just do that. 1 times 5 is 5, so write a 5 under the 7. Everybody okay so far? I'm going to do the same thing with this one. I want you to see that the steps, you probably wrote too big. Just use your finger.
That's nasty.
There you go. Okay, same thing here. I'm going to take this term up top,
That's hot.
and it's going to multiply around. Now, when it multiplies around, it multiplies to everything outside, okay? So it's going to multiply to this and this. Y'all ready? No. X squared times x is what? X cubed. Put it in the column that it goes in, okay? X squared times negative 2, negative 2x squared. Yep, that's exactly right. All right, what's my next step over here? Subtract, right? Subtract. 7 minus 5 is 2. Okay. Over here, I'm going to do the same thing. I'm going to subtract, but be careful because I am subtracting everything. So I'm going to put some parentheses around this whenever I go to subtract. Okay. X cubed minus x cubed. What happens? It cancels. Your first term should always, always, always cancel when you do this. How about 5x squared minus negative 2x squared? 7, right? Be very careful with this because your signs are changing and it's every sign in here. So since it was negative, if you like to do a same change, do a same change everything, or you can put it in parentheses like this, but remember I am subtracting. All right, everybody okay? All right. What now?
Bring down the 3.
you bring down the next number, right? So bring it down. And I'm going to do the same thing on mine, and I'm going to bring down this minus 7x. That's a minus. Okay? You see how the steps are exactly the same. Okay, maybe not. All right, now what? Look at Casey's problem and tell me what we do next. That's right. 5 goes in. Now we start this whole process all over again, but this time we're using 23 instead of using the number in the house, right? So 5 goes into 23 how many times? Or 5 times what gets me closest to 23? 4, and you put it up top, right? Same thing here, but only using, again, this outside term and the first term here. X times what gives me 7x squared? 7x, and it's a positive 7x, so I'm going to say plus 7x. That's okay. What now?
Minus 20.
But what'd you do to get 20? Where'd 20 come from?
5.
Okay, so we're multiplying around again, right? So I'm going to take the same one, and I'm going to multiply around, but it multiplies to everything. I knew it. Right, 20. Okay. 7x times x is, and 7x times negative 2. Okay? What now? Subtract, right? But when I subtract everything. First terms cancel, as they should. Negative 7x minus negative 14x leaves me with what? Positive 7x. And we're in this constant loop now, right? You finish your problem, I'm going to finish mine. Stop when you get to the remainder, when you can't go any further. Right, so I'm going to go one more loop here. X times what? Or actually, I forgot to bring down the 2. X times what gives me 7x? 7. That goes up top in the constants column, and I'm going to multiply all the way around. 7 times x is 7x, and 7 times negative 2 is negative 14. Subtracting everything. First ones cancel as they should. Don't do that. Don't do that.
Finish it.
No, finish it, but don't. But whenever you get to where you can't go anymore, stop. So take that decimal off. Take that decimal off. I'm gonna do it a different way. You want this? You want this tissue I was using to erase it before?
My thing's already here.
You wanted the job, I'm just saying. All right. 2 minus negative 14, 16. There's nothing else to bring down. We're in the same boat that Casey's in over here before we start adding decimals and whatnot, because I don't want to add decimals to a polynomial, so I'm going to do this a little bit differently. Some of you have already said this, but what do we call what's left? The remainder, right? Casey's remainder over there is 4. Mine is 16. So my question is, in that circumstance, if we don't do a decimal and add zeros and keep going that way, how do I deal with a remainder? Does anybody remember? Okay, without an R. Everybody always, I forget about the R. Without the R, a little bit more mathematically correct way. A fraction, you're exactly right. How do you make the fraction there?
The remainder over the whatever.
That's exactly right. So it would be 1,464 and 4/5, right? So do your 4/5 up there. Over here, it's going to be the exact same thing. It's going to be my remainder, and I'm always going to be adding it if it's positive, subtracting if it's negative. 16, that's my remainder, divided by x minus 2. And so that's how I deal with my remainder. So what do I get when I divide these two polynomials? I get x squared plus 7x plus 7 plus 16 over x minus 2. What do you think? It's a lot of work, is it not? I'm going to teach you a shortcut soon, but not yet. I'm going to struggle a little bit because it doesn't always work. All right, let's do another one and see if we can get it. Thank you, Casey. That's all. Then you can stay there if you want. I want you to tell me what you notice is the same or different about this one. It's missing the power of 2. That's exactly right. Power of 2 is not there. And so I need a, what's it called? Placeholder. So here's what I'm going to do. I'm going to hold the place with a 0x squared. So that I still have I still have the squareds column on there. It's just going to have a 0 to hold its place. So let's set it up. I got x minus 8. That x looks wonky. I'm sorry. Into 8x to the 4th minus 64x cubed plus 0x squared plus 3x minus 20. While you're writing that down, how would I know if I didn't have a remainder? What happens? It just goes to 0 at the end. When you subtract, everything goes away, and that's okay. That just means it went in evenly, and you actually divided by and have a factor. All right. Somebody tell me my first step to do here. Thank you, Ryan. Yes, you're exactly right. How many times does x go into 8x to the 4th? Or what do I need to multiply x by to get 8x to the 4th? 8x cubed, right? So I'm going to go to the cube column. I'm going to write 8x cubed. And I'm going to multiply around. 8x cubed times x is what is that? Oh. 8x to the 4th. And 8x cubed minus 8. Y'all can do this. Look at this. Oh, what the heck? What happened? They all canceled out. That's okay. I get 0 and 0, but I'm still going to bring down my next one. What is the next one? 0. Can I multiply this by anything here? No. So I'm going to bring down the next, and I'm going to, in fact, keep bringing down until I have enough to multiply through. So here, because this has 2 terms, I need to make sure I have 2 terms here. So I'm actually going to have to bring down all the rest of them, which is okay. You can bring down as many as you need when you start bringing down. I'm going to ignore this one for right now so it doesn't confuse anybody. So now my question is, x times what gives you 3x? 3. I'm going to come over here to this column because that's the constants column. You'll see why we're keeping them in such order pretty soon whenever we get to the shortcut. And then I'm going to multiply around again. 3 times x is 3x. And 3 times negative 8. Subtract. Negative 28 minus negative 24 is negative 4. So that's my remainder. So when I divide these, I get 8x cubed plus 3. And then I do remainder over. And you can do plus negative 4, or you can do minus 4 over x minus 8. What do you think about long division? Yes.
So that's your answer.
That is your answer. Yay or nay? Can you do it? Let me give you one to try while I run a different sheet than what I have because it's foul. I'll give you an easier one. There you go. Try that with you.